product development to introduce the team and kick us off.
Thanks, Brian. So we have on the call Jason Hoffman, our president and CEO, myself, head of product, and we also have Jim, our senior principal engineer, where together we'll do a quick product overview, product pitch, and then go into product demo. Like Brian said, interrupt at any time if you have any questions.
Yeah, great. Yeah, thank you for that, Wanho. So MobiledgeX was a company that was founded by Deutsche Telekom. We started in the very, very beginning of 2018. We aim to engage with like the top 25 operators globally. We currently have footprints with 16 operators, across, I think 13 countries, in there. And there's still currently a mix of pilot sites within enterprise and government customers, or the other sort of majority of them are now actually converting into commercial points of presence as well. We are a trusted control plane and automation system in the same locations as core and access. Part of that, of course, is because we've gone through pretty about 18-month long product acceptance, security review, and global certification efforts. The one typically goes when you have this type of presence in those sites, and then we have a very large sort of ecosystem building effort within the company as well. We've been standardizing our APIs and SDKs as part of Linux Foundation Edge, and have been leading the Crano API project in there. All the various GSMA groups, in that, and continuing to work with sort of the broader community. So we of course have a globally accepted product, in the space. Continue doing the ecosystem building, and then we engage with a lot of companies that are doing use cases, in the space. Everything we do is also fully documented. So literally it's, developers and operators.mobiledgex.com. The console that we'll show you today is console.mobiledgex.net. It's a publicly available, console and experience that people can use. And as I see, even sort of recent highlights about some things here is, we've been deploying aspects of the network itself, on the edge. So both the 4G, 5G core, and say parts of Open RAN, VNFs and so on like that. And then, some, of course, other use cases that span across multiple operators. If you go to the next slide, please. Now, when we look at a number of these, there's essentially about, 4 classifications of edge native applications you begin to think of. So there's the network itself. So as we said there, also these types of streaming applications, where there's actually events occurring along a bidirectional stream. When we sort of look at it another level down, that tends to be the content delivery optimization that you see here, video analysis and machine learning, aspects of gaming and Industry 4.0, or these types of flow applications. We also do a lot of applications around the immersive and pervasive space, in there too. So that ends up landing in a lot of Industry 4.0, gaming and entertainment, too. And then I'd say, the 4 sort of broad categories really around autonomous control systems. So things that are around devices that move a bit on their own, whether it be industry, sort of factory or warehousing, robotics, hospitality robotics, and then a number of use cases around devices that are out there behaving in an autonomous fashion. Go to the next slide. So I think what we'll see, and Wanho will cover this a bit, is that we've been managing these sort of 3 communities, if you will, around what we do. One is, what is the developer experience for consuming edge that's meant to span multiple operators and multiple networks. So really sort of a great consumption experience. At the same time, the operator community, about what it takes to actually operate edge. So Wanho will cover there. And as we said, then bringing these two together into emerging devices, emerging use cases, and actually, helping the space drive forward. So why don't you take it from here, Wanho?
Okay, thank you, Jason. So as Jason pointed out, for last 3 years since the start of the company, we had a privilege to work with a lot of developers who work on various type of edge use cases, and also with telco vendors where they provided us with the requirements to fulfill their needs. The slide here shows some of the high-level features that we have developed to fulfill those requirements. The first one that I want to talk about is the Unified Self-Service Console. So what this is, developers were asking for a simple platform where a unified way of access is provided in a global and non-fragmented way, so that developers can autonomously manage their software deployment across all operators' distributed edge infrastructure. The second one that I want to talk about is the application types. While Kubernetes is the widely adopted deployment type these days, there are still a lot of developers out there where they prefer other deployment types. As a result, the platform supports Docker, Docker Compose, Kubernetes manifest file, Kubernetes Helm, virtual machine as well. And as you see in the previous slide, a lot of applications that are deployed on edge require a heavy use of GPUs. So the platform supports GPU and virtual GPUs.
Well, and one thing I'd like to, just interrupt Wanho here is that, the virtualization of GPUs is a functionality that we did together with NVIDIA. And it actually includes complete device management, device driver management, and most importantly, it conforms to the entire licensing scheme that exists around virtual GPUs, and it is a unique aspect of the platform overall.
So once the application is deployed, we wanted to give operators a good operational experience of lifecycle management of their application. And we do that through various features that we have developed, like the health checks, alerts, monitoring that includes different logging schemes, like the audit log, events log, and usage. I will go over here. While developers can use the platform to manually deploy their application across different locations and operators, but developers can also choose to use our declarative autonomous application deployment service, where this is basically a policy engine where developers can define a policy and let the platform do the application management. So once the policy is defined, the platform will automatically deploy their application when and where they're needed. So you see a demo on this today. As we work with a lot of developers sees edge computing as a location-aware computing. So they want the platform to be location-aware. And we fulfill this requirement by working on different MobiledgeX SDK, which is offered on Android, iOS, and Unity, where application developers, the client-side application developers, can pick one and integrate onto their client-side application. Once it's integrated, the SDK will automatically find or connect to the optimal deployed application instance and form a persistent connection between the clients and the application instances that are deployed on edge. And through that connection, we also provide enriched client and server-side analytics, which we'll see a demo of that today as well. Some of the invisible features that we have developed includes there's no one-to-one integration that are needed for developers to uniquely or individually integrate with each operator. Another one is that as you see in the demo, the experience is very similar to a cloud model. So the developers don't need to worry about underlying hardware on IaaS. They just have to focus on application development.
Now, and this is a very good thing, because like what you'll see in the demo today is even as Jim is demonstrating some of the application mobility that occurs throughout a given country, one thing I want to point out there is that those back ends, as the application is moving through the country, is actually on different target infrastructures, different providers, different operators. And we'll actually see that sort of migration across, literally different providers from a back end perspective in the demo today, from an invisible standpoint.
So the platform is unique in that we provide different features and services that we offer to a developer, but the same platform can be used to serve our operators. And the slide here shows some of the product features and services that we have developed for the last couple of years. So first one that I want to talk about is the infrastructure agnostic. As you guys are aware that operators tend to shy away from anything that requires a vendor lock-in, as they want to maintain or have a control of the hardware and IaaS vendors that they work with. So the platform is architected to be infrastructure agnostic, so that the platform right now supports to run on top of OpenStack, VMware VIO, VMware VCD, and VMware vSphere as well. And we also have support for bare metal Kubernetes, and the platform can also work across different hyperscalers. Once the cloudlet is onboarded onto our platform, we wanted to give operators a good operational readiness. So we want to give them a control of their infrastructure. This is important because, as you all know, operators want to have full control and visibility of any workload and application that are provisioned onto their network. And we do this through different features that we have developed that include resource management of their resources, health check and alerts. We also have ability to generate periodic reporting, schedule reporting. If there's a Kafka cluster available, we also have ability to send events and log to the Kafka cluster. And similarly, we also support different logging, such as audit log, events, and usage. I'll go over here. As operators are planning to scale out their network with 5G rollout, they're also looking us as a platform to easily onboard their cloudlets, or they're looking for a feature that helps them to automatically onboard their infrastructure. So we have this feature called one-touch cloudlet onboarding, which allows operators to easily and quickly onboard and make them available for use.
And this will be something we show today. And I think what you'll see in the demo as well is it takes a matter of minutes for us to basically onboard any sort of existing infrastructure that's present there.
Once the cloudlet is onboarded, it is by default a public cloudlet, which means is that any developers who is interested to deploy their application can deploy there. But sometimes operators want to maintain their customer relationship and also want to have a full control of what gets deployed onto their network. So that we have a feature called private cloudlet. And once that cloudlet is turned into a private cloudlet from a public cloudlet, operators actually have a full choice or full control of what gets deployed onto that network. Being security compliance was a key requirement by the operators, so that our platform is built with security and privacy in mind, where we have our own key and secret management, data residency, and we also have our internal and external PKI.
And with our operators, mobile network operators we work with today, we've had third-party penetration testing on this. We've had full code reviews. We've had full security scans and everything else, and made it through all those processes quite well.
So debugging any fully distributed system is really, really difficult. So we have spent a lot of time building a scalable distributed debugging logging architecture to help us understand and debug a very complex distributed environment. Last thing that I want to talk about is the whole operator-specific security. So based on our experience working with operators for the last couple of years, the product has confirmed to work with different network and security requirements provided by each operators. So
just a quick question, Ajit does. So you have this infrastructure agnostic bullet point on the very top. That kind of popped up my eye because we see that many cable companies are also deploying the MEC on the edge, right? And so do you think your platform, although it says mobile network operators need, so it can be used for like other providers as well? Or?
No, I mean, it can be, so on the infrastructure agnostic, it largely means that concepts like hybrid and multi and everything else is just sort of feature points for us. We were founded by a mobile network operator, and we're still, of course, majority owned by Deutsche Telekom, and that was where we went and did things first. There's nothing about what we do that is necessarily, solely specific to that industry. I mean, what would be applicable to anybody in the cable space, broader enterprises going and building out, private 5G. I mean, a lot of ways, it's one of the better distributed systems out there that even sort of manage, a lot of those types of environments. Where we came from, particularly in sort of the mobile networking space, is, in a lot of ways, it's literally the computer history museum of infrastructure choice, in that. And so I think, it's that sort of infrastructure agnosticism and that approach of like, well, let's just go ahead and use whatever you have.
Yeah.
I mean, all the solutions that is being deployed in the cable space, we would literally be able to onboard in a matter of minutes as well.
Yeah, I mean, that's what I thought, because, if you're managing the application, if you're managing some of the network workload on the edge,
Yeah.
then that could be like any kind of network workload, right? It could be like from the cable, could be PON, could be anything, basically.
Yeah, exactly. Yeah, and that's not that's sort of not a problem. And once an application's onboarded onto this, like we said, we support all the known MEC environments. We support all the OpenStack variations. We support every single product that VMware has in the space, which I'm not even sure that the other parts of VMware support every product from VMware, in the space. Also the on-premise products from Amazon, Microsoft, Google, and their public clouds, because that ourselves is our own sort of target points. So in a lot of ways, it's one of these things where, you could go ahead and pick Outpost, pick Azure Stack, pick Anthos, use GCP, use AWS, use Azure, go ahead and have a MEC product from, Ericsson, Nokia, Huawei, take your sort of pick, go ahead and have some OpenStack things from over there. Got a little sort of heterogeneous mix of VMware trying to experiment with sort of GPU farms. Great. We'll actually pull it off into one common system that at the very least will give you a complete understanding of it, complete metrics, monitoring, debuggability, and, essentially then have that type of service for developers where we do end-to-end deployment from device into that edge and then even overlaying the public clouds. But yeah, that's exactly the approach there.
Great, thanks.
So before I unshare my screen and have Jim walk through the demo, I want to share a slide that kind of shows you a flow of what will you see as part of the demo. So as I mentioned that instead of deploying an application in an imperative way, we'll do it through a declarative way by defining a policy. And then we support two policies. You'll see two policies that are part of the demo. One is a high availability, and the other one is the auto provisioning. High availability allows the application instances to be deployed at a minimum cloudlet to a maximum cloudlet. And auto provisioning policy allows you to automatically deploy an application based on where users show up. Once the application is deployed, we'll use the platform to see how some of the metrics are captured and how the data can be used by the developers to enhance their end user experience. And that information also can be seen by the operators to see if a new cloudlet can be onboarded to a location as users show up and that as their end users show up in the location. So I'll unshare my screen and have Jim do the demo.
Thank you, Wano.
Hey, thank you, Wano. Can everybody see my screen?
Yes, sir.
Okay, so this is our MobiledgeX staging environment. It's basically identical to the production environment. I'm going to log in here to the console using my credentials. And it takes me to this organizations page. So we've got two types of organizations, as I think Wonho mentioned. We have organizations that can be developers who write applications, want to deploy applications, and we have organizations that are mobile network operators, or anyone that runs a data center effectively. For this part of the demo, we're going to be focusing on the developer side. So I'm a member of these organizations, and I can kind of switch gears and manage whichever organization I'm a member of. And as I do so, you see the menu on the left changes. So as I go over and manage this Computer Vision Incorporated developer, I've got a set of menus here applicable to an app developer. So the first thing we're going to do is onboard an application. So I'm going to go over to apps, and I've got an application defined here. It's the definition of an application. I'm going to click on this to get a little more details of this app called Computer Vision 1.0. You see it is a Kubernetes application. One who mentioned we support VM-based, Docker-based, Helm-based, etc. But this one is just plain Kubernetes. The complete Kubernetes manifest is here. This one was auto-generated by the code. So if the developer just wants to enter in what ports they want to be accessed and what image they want to load it from, we'll generate the manifest for them. Or they can provide their own manifest, or it can be a combination where we create a manifest and they edit it as they need to tweak any details. But this one was auto-generated by the code. You see what ports it has exposed, and it generates Kubernetes service manifest inside here. So I'm going to close that out. As of now, we don't have any instances running of this app. So if I go over to app instances, you see it's not running anywhere. So I've got it defined, but it's not running, right? To show you where it could be running, I'm going to go to the cloudlets menu here. I'm going to focus in here on the US, make it a little easier to see. These are all the cloudlets that this developer is allowed to deploy to. So if there's a private cloudlet that it's restricted the usage of this developer, they won't show up here. But these are all the ones that he's eligible to deploy his app to, okay? But again, none of them are actually deployed right now. So one way, the simple way to deploy the app might be just go here to applications. I can just do a create instance. I could select one of these operators. It could be Google Public Cloud, it could be this Global Wireless, it could be Azure, whatever. And I could pick the cloudlets and launch it into those cloudlets, and the application would be onboarded. I'm not going to do it that way for this demo because Wonho mentioned we want to show you some policy-based deployment, show you a little more advanced functionality than just a manual deployment. So I'm going to go over here to policies, and we got something called an auto provisioning policy. Auto provisioning policy called My Auto Policy. Click on here to show you the details. A couple aspects of this. So when you see the minimum number of instances for this policy, that indicates that if I apply this policy to an application, I need at least 2 instances of this app running at all time for high availability, essentially. Right, so it's going to deploy at least 2. And then we have these deploy request counts. This is basically the number of clients nearer to a better edge location that would trigger the application to be onboarded into that edge location. So if even one client, for example, gets near a cloudlet that doesn't have the app running, the application will be automatically onboarded to that cloudlet if it's in this list of cloudlets that I've selected as the ones I'm interested in onboarding to. And I can say, what's the maximum number I want to onboard? No more than 20, let's say. Okay, so that's how the policy works. Now, as of now, the policy is not associated with the application, which is why, again, we have nothing running here. But I'm going to go back to the application and just do an update. I'm going to edit this application. I can edit whatever I want in here, but I'm going to check these auto provisioning policy. I'm going to go find the My Auto Pro policy, associate it, and just update the app. It's now updating the definition of the app, but if I quickly go over here to app instances, you see it's already spinning up 2 instances of the application right now. And that's because that policy said I need at least 2 instances to run for HA. So as soon as I associate the policy, those first 2 instances start to spin up. It'll take a variable amount of time to do that. This one is still running, okay. So as it runs there, as that one spins up, I'm going to switch gears a little bit and show you the actual application. So the mobile application is running, and you see he sees both these 2 application instances have been launched. It's a little cluttered here on the screen, so I'm going to move over a bit. Now this application, it could be anything really. In this case, it's kind of a demo application that shows you more of our APIs. It shows you what's going on. If this were an AR, VR application from a normal developer, probably these SDK APIs would be generated, would be built inside the application. But here we've kind of separated them out so we can show you exactly what happens. So I go in here and do a find closest cloudlet. It's going to immediately pick the one in Dallas because that's where I am. I'm close to Dallas, right? At this point, Wonho mentioned we have a persistent connection to this app. So if I move around, if I go closer to Florida, to Miami, automatically that persistent connection is going to reconnect me to the better cloudlet, which happens to be in Miami, because that's
And what these guys mean is like we have this feature we call edge events that is this real-time bidirectional stream that always exists between our SDK, on that application and, the nearest, cloudlet site. And then each, of course, cloudlets actually communicate with one another. So as it moves around, we can migrate that entire sort of application backend and network identity over to the next spot.
right. Now I've got these two cloudlets were pre-existing because of HA, but you saw I had a policy where I could deploy into other places if I go to a better location. So if I were to pretend to roam over here to South Texas, here I am still connected to Dallas. But if I go back to my screen here, you see it actually already spun up, if I refresh my page, the third instance of the application, because San Antonio happened to be closer to my location than Dallas. So the Dallas and the Miami were spun up by HA, but this new location was spun up simply because the mobile got closer to that location. Okay, and if I go to another location with another cloud, the same thing will happen if there's a better location for that mobile. And again, we can set that rule based on a single client, or we could set it based on 100 clients, right? But for the purpose of a rapid demo, we'd set it very aggressively. So that's a single mobile, but to give you a bigger picture, what I'm gonna do is kind of quantify that out. Move back to this page. So I've got the 3 instances running right now. The 2 are proved and 1 because of the policy. What I'm gonna do now is start like a traffic generator, basically to simulate some more traffic in the rest of the country. I'm gonna run that now, and this is basically gonna generate clients all throughout the US and basically call our APIs to register and do this find cloudlet API call and see what happens. If I refresh my page, what I start to see is more and more application instances start to spin up on all these locations. Every eligible location, when there gets to be a client near there, it's going to keep spinning up these apps. Okay, so that gives you kind of a view for how it would work in a broader perspective. To give you a little more feel for what's going on here, I'm going to go to the monitoring page now. And I'm going to pick some average stats. And you see it's starting to collect already the normal type of stats for all these instances that we've launched, right? CPU and memory, all that kind of stuff. But more interesting than that, I think, is kind of the advanced stats we have, which is the latency stats, which I think is a little more unique to our product. So I'm going to show you that. So I'm going to go to show latency metrics. And you can wait a little bit. Okay, we'll pick a particular location. And still waiting for my latency metrics. There we go. Okay, so it took a couple minutes for the traffic to collect all the stats, but here we go. We've got some latency stats from various locations.
Maybe you can zoom in on the US a bit.
Yeah, let me get a little closer. Okay, so here we have the cloudlets we have, and these represent these location tiles of users that are a particular distance away from the cloudlet. So you see that for this tile, the number of samples, basically a lot of high latency samples, so it turned red. This one also not very good. But for each tile, it gives you a view, or I can pick another one. For every location that's accessing that cloudlet, what kind of latency metrics are we getting for that cloudlet, right? So as the stats continue to roll in, we'll get a better and better picture of what's going on here. And as you get a lot of stats, you can actually export these to a CSV file. And here we go. So I'm going to pull these stats up and maybe shrink it just a little bit. Okay, and you see the data is starting to collect as it goes through and it looks at each cloudlet location.
And the CSV file is just one of many export possibilities. All of this also goes into, real life data feeds and everything else they can pull into another system or some other data lake or some other sort of, analysis as well.
Yeah, exactly. So you can see it here in a simple way from the CSV file, but to really do analysis and make decisions on that data, the operator themselves could be exporting the data through whatever analysis tool they want to use and make decisions on that, right? So
they might have a question of things like, Well, like what percentage or what type of devices and clients are not being well served from a latency or performance perspective, and should we go and actually stand up another site? Do we have another site present, and so on?
Right. And one thing they might notice right away if they're looking at the stats is, if there's kind of a gap here in the Northwest, for example, right? That maybe we're seeing a lot of clients out here with bad latency profiles. And you know what, maybe if we had a cloud here in the Northwest, we'd be serving customers better. So I'm actually going to show you that now, because we actually do happen to have a data center, an Equinix data site in the Northwest. And we're going to go kind of shift gears now to the operator focused side of the demo and show you how we would onboard that cloudlet. So what I'm going to do now is go back to the main page, go back to organizations. And I'm going to switch over, no longer doing computer vision incorporated. I'm going to manage this global wireless operator. From there, I can see my cloudlets only for my own operator. I'm going to focus this again to the US. And you see there's nothing up here in the Northwest. So what I'm going to do, we actually have a data center running bare metal Kubernetes that we're going to onboard our platform to. So I'm going to show you how that works right now. So I'm going to click the plus sign. This is going to be US region. I need to give it a name. So I'm going to put this is going to be actually in Seattle in a data center. I've got a latitude. And I've got a longitude. Take out of my notes here. To specify how many public IP addresses you have.
Yeah, and as they do that, because when an operator does onboard a site, we of course take a pool of IP addresses, and on both sides of our own clusters, we do like large scale load balancing, NATing, all the sort of end-to-end management, like in that.
Now the platform type here is going to be Kubernetes bare metal, but I think Juanjo mentioned a number of these other types: OpenStack, vSphere, vCloud Director. There's a couple more not listed here that aren't supported through the UI, such as the hyperscaler ones, but there's probably close to a dozen different platforms we support. And this is going to be Kubernetes bare metal, and this is going to be Google Anthos based Kubernetes, by the way. Based on the platform type, there's some extra kind of fields that need to be populated. So because it's Kubernetes bare metal, it's asking me for the control IP address, it's asking me for an interface name, and it's going to ask me for the public IP pool, the range of which of IP addresses I'm allowed to allocate. Additionally here, there's some other things we can do. We can set resource quotas to generate alerts. I'm not going to bother with that for this. Some more advanced settings, so GPU driver settings. I think Juanjo mentioned we can export things to a Kafka cluster. So if we have a Kafka endpoint, we can set it up here and export events directly to it. Not going to do that for this demo.
And the trust policy that you've seen here, as well as on the developer side, is basically the public versus private out, cloudlet, and who's allowed to sort of access it, and ingress and egress traffic as well.
So I'm going to take a quick look over, make sure I didn't make any mistakes. I've got a name here, a Latin long, number of IP addresses, Kubernetes bare metal. I filled in my parameters. So I'm going to click create now. And it should pop up here a progress window, which it did. And you see what it's doing now. You might be familiar with the technology called Chef, which is an orchestration technology. We use it for the lifecycle management of our platform itself. And what it allows us to do is the operator can manage all the upgrades and management of our platform from a single location on a Chef server. And Chef is advantageous for this reason because Chef makes basically a call out from the client endpoint back to the Chef server, which a lot of the operators prefer from a security perspective. They don't want us trying to log in to manipulate.
Yeah, and we found, this of course in the early days was something like, do we actually go and take on this aspect of management ourselves, or do we do something else? And Chef itself being an entirely declarative model and being something that's been increasingly used in the operator space in there. And we said, well, the easier thing to do is to basically sit down and also treat that as a sort of a point of interoperability with what a lot of the guys are doing from a rollout perspective.
So you see, this is already done. Yeah, it might have taken a minute, but I'll just highlight a few things. So one of the things it's doing here is it's reaching back to our control plane. So all the connections from the cloudlet are from inside out, because they don't like connections being made in as much as possible. So it reaches out to the control plane, and there it gets its configuration, and there it starts. The platform processes up gathers some metadata, et cetera, reports that back to the control plane, and then it's basically ready to go. Now, at this point, this is now a quote unquote public cloudlet. It's available for anybody. If I want to make this cloudlet restricted to where only certain developers can onboard to it, I can go to this cloudlet pool concept. I've got a couple pools here already just to show you as an example. Pool of cloudlets. There's only one cloudlet in here, only one organization, but basically you can go in here and you can say, invite organizations to your pool, or you can add cloudlets to the pool. And unless that organization is a member of that pool, it's restricted. They don't see it. They're not allowed to use it, right? So it's kind of how we divvy up the permissions on who gets to see that.
Well, and I think, and we've done, candidly, the team's done this is one of the sort of approach to multi-tenancy and how you allow a many-to-many engagement model in a distributed system is one of the harder things to do. I think in general, the way we've done RBAC in this system, is such that concepts of public edge, private edge, hybrid, multi, the idea that we have those are all just policies that we apply to this overall system. It means that, even here, we can have a one-to-one relationship with an end person that's got access to the system, but that person can belong to multiple development organizations over time. Those can sort of come and go, and how that occurs gets automated. They can be in multiple operator communities. And so, we've basically taken how we do the operators, how we do the development, how we do an individual, and allowed, policy-driven type interactions within that distributed system, if you will. And then, a lot of what other people call of, well, how are we going to do private? How are we going to do public? How are we going to do a campus? How are we going to do it on a public cellular? How are we going to do it inside of here? All of that just becomes policy-driven choices that one applies to the system.
So that concludes basically what I had for the demo to go over. Do we want any questions or aspects that people are interested in seeing, I guess?
I think one thing, if you pop over to the developer view again, on here, we talked about the auto provisioning policy. For us, that's, again, our viewpoint is that end developers will want to just seamlessly consume things across multiple points of presence, multiple operators, and have that be entirely automated in a very declarative, fashion. That auto provisioning is, a key part of that. And even the footprint you saw here in the US is across multiple technology backends, multiple providers, multiple networks, in there, but it's one provisioning, system as you go sort of across all of them. It's not the only policy driven. And so there's also trust, which is basically around, whether the application is going to be public or private and how you're going to control the egress and the like. There's auto scaling. There's also things around alerts, and the alerts can literally be across any metric that you sort of go and like. So you can do latency-based deployments. You could do bandwidth-based deployments. You could do sort of, are we actually getting, enough sort of frames per second processed on a virtual GPU? And all these can be combined. So you can sit around and build up a set of policies around an application where you say, we're going to auto provision it to locations based on number of clients. And, we're also going to have a performance view of what we're going to go and do that. We're also going to have some segmentation where there's both public and private and A/B testing, and all that can occur within the trust policy. And oh, by the way, if we're going from 100 end users to 100,000 end users, there's also auto scaling within that. And, it's really a sort of combination of those sort of four policies as one develops it for, their end customers and end applications. It really causes, that to occur. And of course, a lot of the things there, when we can collect generalized metrics across this, we can pull that up and we can feed that back to our operator community, from, a planning perspective as well, that when we look at what these demands are and what it looks like, then, you need to be ready on the following timeframes with sort of a footprint that looks there, or in many cases, like in the US, some of these points of presence, as he said, it's public Azure, it's GCP, it's an AWS site, so if we can basically go ahead and meet these policies by then just deploying something on a public cloud, we'll do it, because we're really sort of functioning as that end-to-end overlay. But I think the last thing is really sort of the combination of all these policies is where a lot of the developer power comes into play. But thank you for that, Jim. And then on this point, then we're heading into any questions, comments, concerns, thoughts, anything else we can basically explain while we have our time together.
Hey, Jason, it's Craig Matsumoto with 451.
Yes, of course, Greg. Good to see you.
Hey, yeah, good to talk to you guys again.
Yeah.
This looks really cool. How does the billing work? Or if I'm a developer, how do I find out how much stuff I've used and what I pay for it?
Yeah, I mean, it's essentially all of the metrics. I mean, what we're doing right now with, when developers come and sign up at console.mobiledgex.net, we're doing, a review from a support perspective and getting those developers onboarded. What we're doing as an operator community right now is we're not charging in developers that engage with us. And so, meaning we're trying to actually get things going, from that perspective. When you do look at the billing, that is yet another data feed that we have, around resource usage. Again, the nice thing about the many-to-many RBAC model that we have is that an end developer organization might actually be owned in a given country by a given operator, and they're going to go ahead and handle that relationship, and we're giving them all of the data to then go do that. And they could charge based on adaptive managed latency. They could charge based on, frames per second in a GPU. They could charge on a VM or a container basis. They could charge on a traffic basis. I mean, whatever sort of resource per unit time type metric that they would like to go and do. For some of the end users, like some of the device makers and other more global companies that we work with, in that case, they're actually expecting that type of resource per unit time platform and SaaS pricing to come from us. And in that case, we send them a bill for that type of usage across the type of thing. And then we flow it back to our base operators. We almost sell a SaaS service with some PaaS pricing, and then we pay an IaaS back end is sort of a way to think about it. But we have a full, all the data needed to do it inside of it, and then all the interfaces to go enable that model.
So just to add, it's actually the engineering team also, we already have integrated into a billing platform, except it's not enabled yet, right? Just as Jason mentioned, is right now developers are using the platform for free, but we already have a billing platform where all these metrics are fed into, and we can actually generate invoices. And the way we invoice our developers are based on the similar to a cloud model, right? Depending on the CPU usage, but we also can charge based on API usage as well.
Yeah, we can. I mean, literally, full set of metrics go in. You can go build a structured product around any resource per unit time that you'd like to go and do that. And then we've set that up in a wholesale retail format, where we can be the retailer and the wholesaler, or we can be the wholesaler and an operator can be the retailer, or we can be the retailer and they can be the wholesaler. And so, we've basically, again, structured that many concept throughout the entire platform. I mean, both in the adoption of what infrastructure we go run on, what networks we can consume, who basically owns the end customer. How do we have a long-term relationship with like an end developer, even as they move across different companies and consume different clouds? But at the same time, how do we have a relationship with that company and the operator too? We've basically baked all of that into a good distributed system here that we apply policies to at sort of each and every level. Answer your question, Craig?
Oh, yeah. No, it all sounds very flexible. And I guess related to the many model, maybe I want to make sure I understood the relationships that happen inside of the system, because you talked about developers could have permissions across multiple operators, it sounds like, and developers could belong to multiple organizations that themselves have relationships with different operators. I'm just picturing all of these
Yeah, I mean, you could have somebody, for example, that's employee at a place like Ericsson that's responsible for deploying out different VNFs and trying some different things like that, and they're on a development team. They could also have a side gig where they're working on some other application that they're trying out themselves. For here, they would be the one person like that, but they would belong to two different development organizations. And then if they leave an Ericsson and go work at somewhere like a Deutsche Telekom, then they might get operator access to the Deutsche Telekom footprint, but they also might be a developer with a Deutsche Telekom. But then the Ericsson stuff gets retired out as we basically sync up with, their own access environments in there. But we've like kept that relationship as a person. I mean, one of the, funny things is when you look at, for example, like the entire user model that was emergent at somewhere like an AWS, we took a lot of the lessons from the way that was done in a very ad hoc way, in the sense of, the type of thing where you go and have an Amazon account and then you go build up a company, but then, there's no mobility, across these sort of different entities, if you will. But then, that's the approach we took here. So a person could belong to an infinite number of development, application companies, can belong to an infinite number of operators, and then these can all be public or private or multi or connected, however the policies are set up in between them.
Okay, very cool.
Yeah. Yeah. Any other questions?
Yeah, this is Grant from Appledore Research. How you doing, Jason?
Hi. Doing well, Grant. Thank you.
Could you talk about your relationship with AWS, particularly where it has things at the edge, and like Azure for operators, particularly where they talk about their hybrid edge, and where you see yourself in an element of competition versus the clear things that you bring on top of them that you would use? I realize you may work with facilities and theirs.
That's a very good question. I mean, our sort of viewpoint of, hyperscalers is, one, the last year has been interesting because, particularly Amazon, Microsoft, and Google has all emerged as suppliers and partners to, our community. They're promoting a worldview to the telecom sector where one moves as much as possible to their cloud. You implement their on-premise offerings, perhaps resell or use their packet core, and stuff like that.
Mm-hmm.
But their strategy and positioning is pretty straightforward. It's build an edge with us, run your network on it. While you're running your network on it, take advantage of these great public cloud services and our broader ecosystem of application contents. But by the way, you're going to be going all in with us. And I think, one of the best contrasting examples to us right now is really what Verizon has been doing with AWS. You go and you watch those recent things. The deployment into the Verizon sites is still entirely manual. By an end developer. You go and you pick a site, and literally on the very same webinars and Twitch streams that they do together, you have an AWS representative saying, well, if you don't want to pick the Verizon site, why don't you go ahead and pick, just one of our local regions in Boston. And then of course, when you look at sort of AWS Outposts and these types of things anyway, it's got a very limited set of the services on there. It's really just EC2 plus about, 3 other ones. And then things like the load balancing aspect always goes back to the regional sites within AWS. So you're always sort of bouncing back and forth, inside of these networks anyways, sort of in there. And so I think when we look at sort of Verizon plus AWS as probably being the quote unquote most contrasting and mature example, we completely believe that their model and approach towards consumption is entirely wrong. It's exactly the exact opposite of what we're sort of doing philosophically. And even within that relationship, there's a lot of the highlights of, well, almost the type of dysfunction we want to avoid, sort of in there. For us, when we go like in the German market, we're the reason why Azure Stack was placed in the mobile core sites back in 2018. When AWS Outpost was proposed to show up in the labs and the sites there, we said, great, let's bring it in, in that. Same thing with Google Anthos. We've gone and deployed that. So you look at those markets. Now we also sit on top of AWS, GCP, and Azure Stack that's present in the 9 availability zones in Frankfurt. For us, our sort of attitude is, okay, if you have underlying services and infrastructure, we don't care what they are. They can be any of you guys. If we have more diversity there, great. There's more heterogeneity for us to manage, but we just need to know what it is. We need to have a highly precise and accurate GPS location. And ideally, we need to know or figure out what the overlying network topology is. And then we're going to go and give a common industry standard service for end developers that if they onboard onto this using as many all open interfaces and open source and everything else, that they'll be fully interoperable on AWS, Microsoft, Google, VMware, OpenStack, Cisco, Ericsson. We don't care. It'll be sort of like that. And those types of things will freely roam between Deutsche Telekom and Telefonica, DT Germany, DT Austria, T-Mobile US, that it can sort of go and do that. And for us, what we often sort of feed back to AWS, Microsoft, Google is, look, what we can tell you is things are not going and being deployed on something like Azure Stack, for example, because the way that the end customers want it from a policy perspective, it's not the most successful of it. So our approach on there has been, well, how do we have a really good distributed system that promotes interoperability, keeps all optionality open for us from an operator community standpoint, and allows us to actually overlay device, our own networks, and the public clouds. So our viewpoint with these guys is like, well, look, the trade-off is if Amazon, Microsoft, Google ignored the mobile network operator space, that would be terrible. Some of the largest technology investors ignoring it. Okay, that's sort of terrible. But we still want to function as a completely commoditizing overlay where we maintain control and we actually think that we have the better, end developer experience that works across everything.
By the way, if others have questions, I don't want to monopolize it, but I do have two sort of follow-on questions if there's time, and I'll let you and Brian cut me off. So the first is, if we now look particularly at the AT&T core 5G network assets laid on top of Azure, they're making a very unique claim, right? That we have AT&T's assets, which had some issues, but we're going to develop them with their expertise and roll them out, not for vertical apps, but to run the 5G network itself, and then probably add stuff. Or that's so the story goes.
Yeah.
Do you even? I didn't see it in your list. Maybe that is because I'm blind. Do you even attempt to go after that piece, or is that one that you consider separate?
Yeah, so we have pretty much we don't have Vodafone in Europe, but we have complete European coverage. Otherwise, we have the top 3 operators in Japan, top 3 operators in Korea, that type of thing. If you look at the U.S. market, in my opinion, is that over the last few years, AT&T and Verizon in particular have centralized their cores to such and built their networks as such. They don't actually own any interesting assets in the space anymore. In the United States in particular, we work with all 3 tower companies and sort of footprints that they're doing. We've been doing things with Vapor.io. We've been doing things with Equinix. We go and consume local regions from Amazon, Microsoft, Google. So if you look at even our quote unquote US footprint, the majority of it's not AT&T, Verizon, T-Mobile. The majority of it is everybody else that's doing stuff inside of the US. That's a bit more interesting. It becomes one of these things where AT&T and Verizon in the United States alone is very difficult to abstract out to any other country or any other situation in the world. I think the US is really as unique globally as China is, in my opinion.
The final sort of corollary question is, if you were then in some cases potentially to operate as an overlay level that abstracts across many edge facilities, which is a very nice thing, are there any operational or sort of pricing, divide up the money and it starts becoming a lot, issues that you see, you taking your margin for your value added and AWS taking their margin for their value added and the end application trying to get their margin?
Because what we find is that's why from a feature standpoint, all these concepts of managing multiple infrastructure layers and being multi-cloud and hybrid and so on is to our advantage, meaning we can go and just consume bare metal somewhere. We can go and consume Kubernetes on bare metal. We can go and consume, if the end customer's goal is for that bare metal to have GPUs, okay, we can go and actually virtualize that, manage all the devices, manage all the device drivers, manage the licensing around it. But we can also go and provision VMware products. We can go and provision OpenStack products. We can go and overlay on top of, AWS and that type of thing. What we tend to find actually in those engagements is the more large of a footprint we get, the more we can purchase ahead of time, the more we can commit to things. I mean, I can go get a 78% discount on AWS EC2, if we have a large enough volume to sort of go and do that type of push. So there's been enough of a standardization on infrastructure resource per unit time type pricing and enough comparables. And there's enough of a market there, in my opinion, that, it's the buyer's market, not the seller's market, in that. And as long as we basically have the choice of, if we don't like what an EC2 is basically doing, then we're going to go ahead and just get bare metal from an Equinix and then sort of go and do this. And then, if an end customer is setting these types of policies, just the fact that we can go ahead and say, okay, we can roll up VMware inside of that. We can roll up inside of here. We can roll up inside of there. And the total bill is going to look like this and look like this. And some might be up front and some might be on demand and some software licensing or bring your own licenses. I mean, we can sort of take any one of those directions. But I'm not too, that part is honestly so figured out to the point where, there's been companies for the last decade, like Strategic Blue, that functions like a hedge fund on top of, infrastructure per unit pricing, out there. I mean, so I'm not too, that hasn't been, it's such
The
a
buyer's
standardized part of
market
the industry.
comment was telling. Yes.
I mean, it's true though. I mean, you look particularly in the US, you take your pick, and if you're willing to make 1, 2, 3 year commitments into that, then you get substantial discounts. I mean, there's things.
There's your margin right there.
Yeah.
The final question or comment, and just let you comment back on it, is one of the things I found most interesting is what I at least inferred, that you effectively have a cellular-like action in your logic that as a workload moves, at least for the mobile applications, you will see or anticipate that move and move the location policies with it.
And network identity and everything. Yeah.
Yep. And which sounds a whole lot like a cellular handoff to me. And you almost wonder if you could take a feed from that. Or maybe you do.
Yeah.
With the, do you see it with the other competitors out there, do any of them, and I probably should know this, but I don't, do any of them have similar automatic capabilities?
No. So, I mean, we're literally, I mean, our approach has always been completely it's meant to be declarative and autonomous. I mean, like my viewpoint from the very beginning of the company was that, way back in the past, we had static clients sitting on a desk talking to a static backend in a data center. And what it's occurred now is we have completely mobile clients, or at least the mobility is being provided by a human being. But if you actually go and look at the way that cloud deployments have ended up, is they've just been sort of this evolutionary step from the typical enterprise approach, where you have pretty much static deployments done on regions and availability zones and the like, but it's basically just a virtualized version of hosting, like literally, and the way that everything's applied to that. But you have mobile talking to static. We sat down and said, well, if you look at Edge, Edge, in my opinion, has always been a embedded application environment and wireless networks. Now, the wireless, regardless of standard protocol or anything else, can be cellular, Wi-Fi, anything else like that. The embedded application environment and the wired internet that sits globally is what Amazon, Microsoft, Google, is. But we can sit down and say an embedded application environment and a wireless network is what Edge is. And that wireless network might be operated by an enterprise, might be operated by a network operator. The network operator might call themselves a cable operator, mobile network operator, whichever, but that's sort of like what they're going and doing. All those use cases are on a wireless cordless device. And those devices, right now, the mobility is being provided to them by a human being. And for those types of use cases, like on smartphones, the way that we're different, and this is like when you just look at these cases, is we end up having thousands to tens of thousands of instantiations of a back end running for tens of thousands, hundreds of thousands, millions of end users. It's an exceptionally dynamic environment where things are constantly coming and going based on what, real life demands are, sort of in that. Nothing is like statically deployed. And there's a mobility concept in the infrastructure that is on par to the mobility concept that we've seen in the device. And so in a lot of ways, when we sit down and say that we do autonomous mobility of backends today, all policy driven, and that's like, and it's the funny part is when you realize that is actually a prerequisite for mobile devices to start being autonomous themselves as well. Because if there's one definite use case category that the edge could and should own, and particularly network operators in a given country, is all the traffic and control management systems for autonomous devices. That's the kind of thing that's going to be done together with like a civil aviation authority and like a Deutsche Telekom, and it's for like multiple drone fleets being owned by DHL and 9 other companies and sort of the like. So that type of thing, and what we've enabled, on the back end perspective, is that type of autonomous mobility concept for all back ends, and a certain dynamism there that you just don't see on cloud deployments.
Thank you very much.
Yeah. Great. Any other questions, comments, concerns, thoughts, needs? We've kept people 5 minutes over. You're more than welcome to drop off at any point in time, but I also I have a free hour after this. So if you have other questions and you want to hang out a bit, you can feel free to.
I think I'm going to form some new ones. Thank you very much, Jason. Thank you, Brian. Thank you, everyone who
Grant.
presented.
Yeah. Thank you. Thank you.